Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry degree level, chapter Deductions from Demoivre's theorem, lecture number 7, in which I will expand sine to the power n theta. Let x equal to cos theta plus I sin theta. Let this is number 1. Implies that 1 by x equal to 1 by cos theta plus I sin theta. And this is equal to cos theta plus I sin theta whole to the power minus 1. Now we use the concept of Demoivre's theorem for negative integral index, and this will be equal to cos minus theta plus I sin minus theta, minus 1 into theta equal to minus theta. Cos minus theta equal to cos theta, and sine minus theta equal to minus sine theta. Here we write minus I sine theta. This is number 2. Now, x to the power n equal to cos theta plus I sine theta whole to the power n. By using Demoivre's theorem, this is equal to cos n theta plus I sin n theta. This is number 3. 1 by x to the power n equal to 1 by cos theta plus I sin theta whole to the power n. This equal to, here we get cos minus theta plus I sin minus theta whole to the power n. Implies that 1 by x to the power n equal to cos minus n theta plus I sin minus n theta, and this is equal to cos n theta, sin minus theta means minus sin theta. This is equal to I sin n theta, here minus sin. Let this is number 4. Adding 1 and 2, we get x plus 1 by x equal to 2 cos theta. This is number 5. Subtracting 2 from 1, we get x minus 1 by x equal to 2I sin theta. This is number 6. Similarly, x to the power n plus 1 by x to the power n equal to 2 cos n theta, x to the power n minus 1 by x to the power n equal to 2I sin n theta. This is number 7. This is number 8. Raising power n in both sides of 6. We get 2 I sin theta whole to the power n equal to x minus 1 by x whole to the power n implies that 2 to the power n I to the power n sin to the power n theta, and this equal to x to the power n plus nc1 x to the power n minus 1 multiply minus 1 by x plus nc2 x to the power n minus 2 minus 1 by x square plus dot 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 plus ncr x to the power n minus r multiply minus 1 by x to the power r plus dot 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 plus nc n minus 1 x to the power n minus 1 minus 1 by x to the power n minus 1 plus ncn x to the power n minus n multiply minus 1 by x whole to the power n. This is number 9. Case 1. Let n is even. Therefore, I to the power n equal to I square to the power n by 2, and I square is minus 1 to the power n by 2. This is number 10. Second term of RHS right side of 9 equal to NC1. Here we have minus sign, so here we write minus. Here x to the power n minus 1 in numerator and x in denominator, so this will be x to the power n minus 2. Last term equal to ncn means 1, x to the power n minus n is x to the power 0 means 1 minus 1 to the power n multiply 1 by x to the power n. N is even, so this is positive number, so this will be 1 by x to the power n. Last but first term. This is last bar but first term. This equal to ncn minus 1 is nc1. nc1, since nc1 equal to ncn minus 1, and this is equal to x multiply minus 1 to the power n minus 1. This is odd number, so this will be negative, and 1 by x to the power n minus 1. So this will be equal to nc1, here minus, since n minus 1 is odd, so value of this is negative, and multiply 1 by x to the power n minus 2, and this is number 11, this is number 12, this is number 13. Therefore, for n to be an even integer, we may write 9 as follow. Here 2 to the power n, I to the power n is minus 1 to the power n by 2, sine to the power n theta, and right side will be x to the power n, and last term is 1 by x to the power n. Second term is minus nc1, and this last but first term, this will be negative sign. nc1 we take common, nc1 here x to the power n minus 2 plus 1 by x to the power n minus 2 plus dot 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 plus ncr x to the power n minus 2r plus 1 by x to the power n minus 2r plus dot dot dot. Let this is number 14. Using 7 we get 2 to the power n multiply minus 1 to the power n by 2 sine to the power n theta equal to, this is 2 cos n theta plus here minus nc1, this equal to 2 cos n minus 2 theta plus dot 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 plus minus 1 to the power r ncr 2 cos n minus 2r theta plus dot 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 dot. Let this is number 15. Since n is even, then number of terms in right side of 9 will be n plus 1, which is odd. So, if we pair the terms of right hand side of 9, the middle term will be left out because number of terms be odd, and if we pair 2 by 2, the first pairing will be first term and last term, second pairing will be second term and last part first term, and middle term will be left out. In this case, the last term of right hand side of 15 will be independent of theta, because here we have n minus 2r in generalized term. n is even, 2r is even, so even minus even, same even number minus same even number is 0. So the last term will be independent of theta. So it will be obtained for the value of r when n minus 2r equal to 0 implies that r equal to n by 2. Let NCR x to the power n minus r multiply minus 1 by x whole to the power r be the middle term of 9, which is the last term of 15. Therefore, last term of 15 equal to minus 1 to the power r NCR x to the power n minus 2r. Since r is n by 2, minus 1 to the power n by 2 NC n by 2 x to the power n minus 2r equal to n. R equal to n by 2, therefore 2r equal to n, and this equal to minus 1 to the power n by 2 NC n by 2. Let this is number 16. Therefore 15 may be written as 2 to the power n minus 1 to the power n by 2 sine to the power n theta equal to 2 cos n theta minus nc1 multiply 2 cos n minus 2 theta plus dot 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 plus dot 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 dot, last term is minus 1 to the power n by 2 NC n by 2. This is number 17. Dividing both sides by 2, we get 2 to the power n minus 1 minus 1 to the power n by 2 sine to the power n theta equal to cos n theta minus nc1 cos n minus 2 theta plus dot 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 plus minus 1 to the power r NCR cos n minus 2r theta plus dot 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 plus half, we divide by 2 minus 1 to the power n by 2 NC n by 2. This is number 18, which is the required value for n is even. Case 2. Let n is odd, implies that n minus 1 is even. Therefore, I to the power n equal to I multiply I to the power n minus 1, and this equal to I multiply I square to the power n minus 1 by 2, and this is equal to I multiply minus 1 to the power n minus 1 by 2. This is 19. Last term of 9 is NCN x to the power n minus n minus 1 by x to the power n. This is 1. X to the power 0 is 1 minus 1 to the power n multiply 1 by x to the power n. N is odd, therefore minus 1 to the power n is minus 1 minus 1 by x to the power n. Last but first term equal to n minus 1 x to the power n minus 1 multiply minus 1 by x to the power n minus 1, and this is equal to nc1. n minus 1 is nc1. This is x multiply minus 1 to the power n minus 1 multiply 1 by x to the power n minus 1, and this will be equal to minus 1 to the power n minus 1. N minus 1 is even, so this is positive. So here nc1 1 by x to the power n minus 2. This is 20. This is 21. Second term equal to nc1 x to the power n minus 1 multiply minus 1 by x, and this is equal to nc1 here minus this minus sign x to the power n minus 2. This is 22. Since number of terms in 9 equal to n plus 1, which is even, therefore 9 may be written as 2 to the power n multiply I multiply minus 1 to the power n minus 1 by 2 sine to the power n theta equal to x to the power n minus nc1 x to the power n minus 2 plus nc2 x to the power n minus 4 plus dot 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 plus minus 1 to the power r ncr x to the power n minus 2r plus dot 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 plus last but first term is nc1 multiply 1 by x to the power n minus 2. Now we take first and last term x to the power n minus 1 by x to the power n minus nc1 here x to the power n minus 2, and here we have plus sign Here minus, so here we write minus sign 1 by x to the power n minus 2 plus dot 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 plus minus 1 to the power r n c r x to the power n minus 2r minus 1 by x to the power n minus 2r plus dot 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 dot. This is equal to 2i sin n theta minus nc1 multiply 2i sin n minus 2 theta plus dot 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 plus minus 1 to the power r ncr multiply 2i sin n minus 2 r theta plus dot 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 dot. This is number 23. Since n is odd, the number of terms in the expansion of x minus 1 by x whole to the power n will be n plus 1, which is even. Therefore, the terms can be grouped together by taking 2 by 2. Here number of terms is even, so we may take first term and last term together, second term and the last but first term. In this way, we may group all the terms 2 by 2 for. And the last term of 23 will contain sin theta. Here n is odd and 2r is even, odd minus even, and this will remain only sin 1 theta. Subtraction will be 1, last subtraction. And it is possible only when n minus 2 are equal to 1, implies that r equal to n minus 1 by 2. This is 25. Therefore, 23 may be written as 2 to the power n multiply I multiply minus 1 to the power n minus 1 by 2 sin to the power n theta equal to 2i sin n theta minus nc1 multiply 2i sin n minus 2 theta plus dot 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 plus minus 1 to the power r ncr multiply 2i sin n minus 2r theta, and the last term will be here r be n minus 1 by 2 minus 1 to the power n minus 1 by 2 nc n minus 1 by 2 multiply 2i sin theta dividing both sides by 2 and eliminating I from each side. We get here we divide by 2, remains 2n minus 1 and eliminating I remains minus 1 to the power n minus 1 by 2 sin to the power n theta equal to, in right side, sin n theta minus nc1 sin n minus 2 theta plus dot 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 plus minus 1 to the power r ncr sine n minus 2r theta plus dot 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 plus last term is minus 1 to the power n minus 1 by 2 nc n minus 1 by 2 sine theta. This is number 26, which is the required formula for n to be an odd number. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.